Hello everybody, my name is Rosa Mutiara Yuliani. I'm student from University of Jember, the Mining Engineering Study Program. I want to explain to you about my journal review and the detailed evaluation of line Brattice length in an empty heating to improve airflow rate at the face using CFD. For the first page, there is introduction. Introduction from this paper is the ventilation of underground coal mine, especially of turbulent development heating, is one of the most challenging among the mining commodity. This is due to the presence of the methane and coal dust, which are explosive in nature and have been the cause of many major coal mine explosions. Over 330 explosions causing more than 1,036 fatalities. And 532 injuries have been recorded in South Africa since 1891. In this paper, a part of this study is present, which analyzes the effect of the LB length in the relation to the LB wall distance on the airflow rate using the face. This paper further discusses how minimum LB length and LB phase distance are associated with each LB wall distance to maximize the delivery of air to the face. The provision of sufficient supply of air not only ensures the safety of the mine work, but also keeps the operating cost the minimum, since the ventilation system can account for up to 60% of the total operating cost. On the second page, there is a method research. For the first number, research metric and CVD modeling. The following variables related to the LB ventilation system were considered for this paper to investigate the effect of LB length and LB wall distance. The scenario designed and considered for this paper using the specific variable are given in Table 1. We can see at the number 1 until number 8, that is Table 1. And the second number, there is validation case study. The credibility of CFD as an engineering tool depends on the quantification of the error or uncertainty of the results. The validation of a numerical model is therefore required to demonstrate its accuracy so that it may be used with confidence and that the result be considered reliable. And the next slide, there is result and discussion. For all the cases, the general airflow pattern remains the same. Air enters from the upstream side through the alveolar channel and joins the LTR air at the downstream side as shown in Figure 10. We can see on the page Figure 10 when airflow is represented using streamlines inside a heating ventilate using LB. For the next slide, there is the result of this paper. Number 1, 0.5 meter alveolar distance. The results showing on the table 3. And the number second, 1 meter alveolar distance. The result showing on the table 4. For the third number, effect of alveoli and alveolar distance on the delivery of air close to the face. When the alveolar distance is short, the air penetration is higher due to a higher draw. Airflow variation is less, and lesser quantity of air turn before reaching the face of the heating. Consequently, an increase in the length of the LB does not considerably affect the air penetration. If the alveolar distance is higher, however, for higher alveolar distance 1 meter, this effect is very prominent. Consequently, an increase in the length of the LB does considerably affect the air penetration. And the list of contents the presentation, that is conclusion. The effect of the alveoli on the airflow through the alveolar channel and the airflow rates at the face of an empty heating with respect to the alveolar distance was estimated. This estimation was conducted using a validated CFD model. It was shown that for an alveolar distance of 1 meter, higher air flows excited the LB. But a very big percentage of this air returned without even reaching the face. This wastage of air could be reduced considerably by increasing the LB length or by keeping the LB close to the face, less than or equal to 2.5 meter. For longer heating of 20 meter or more, a minimum LB length of 15 meter and 10 meter should always be used with alveolar distance of 1 meter and 0.5 meter respectively. Even with this length, the LB phase distance of more than 5 meters should never be used with alveolar distance of 1 meter or greater. This will not only improve ventilation, but will also reduce the energy cost as an increase in the LDR velocity will not be required to increase the airflow rate close to the phase. Okay guys, thank you for your attention. Bye.